Hello all, welcome to the VoIP Traffic Analysis course on Pentester Academy. Now in this video, we will continue looking at SIP over TLS and RTP and look at how we can analyze and automate some of the aspects with tshark. So let's jump right in. Now in the previous video, what we actually found was that let's actually open up one of the files, Wireshark. And in this demo, we'll use call to voicemail. So what we found was that neither SIP or RTP is actually visible simply because SIP is encrypted. And we can figure that out by looking at the SSL encapsulation information. We can see this is really SIP over TCP encrypted by SSL. And RTP unfortunately is also not directly visible, but we found that RTCP packets are going to be around. And then this allows us to identify the UDP packets around. And we know that we can just right click it, click on decode as, and set the decoder to RTP. And click OK, and this ends up decoding this traffic as RTP. Fantastic, right? Now, this is great, but if we were to go ahead and try and extract the data from the PCAP file by using tools like PCAP to wave, we'll actually see it doesn't work. So I'm going to create a directory called workspace, and then I'm going to copy the PCAP to wave script into the workspace directory. I'm going to copy out the call to voicemail. Actually, I'm going to copy out all the 3 PCAPs in there so we can play with it. Generally like to do this because just in case you end up deleting something, it's inside a temporary workspace directory, right? Okay, so if I were to run PCAP to wave and let's say give it the call to voicemail, and this is SIP over TLS plus RTP. Keep that in mind. PCAP to wave works flawlessly when it's just SIP and RTP. So we give this and we say, well, this is voicemail traffic. What you see is that it doesn't work. It says unable to determine codec from payload type, right? And the same thing would happen if you gave any of the other 2 PCAP files. So the key problem seems to be that, just like Wireshark, these scripts also need some additional information. Now I'm going to show you how to patch PCAP to wave in the next video. But in this video, let's actually understand how we can use tshark and do some of the analysis. And then using this newfound knowledge, in the next video, we will patch PCAP to wave. So I'm going to run tshark. I'm going to read from the file. Call to voicemail, and after that I'm going to apply a filter for RTP packets. We see nothing. I'm going to apply a filter for SIP packets. We again see nothing, right? Now the reason is, just like Wireshark, tshark has no information available. Now this is really where we need to go ahead and give the same decode as option to tshark. So how do we do that? Well, if you do a tshark-d help, you will actually get all the different options available to decode a certain packet as. So if we can scroll up, you'll actually see that these are all the valid layer types. So all we have to do is find udp.port. So let's look at UDP somewhere at the very end. Here it is. So just like in those packets we right clicked and did it, over here we have to specify the layer. So we basically want that the entire UDP packet, the data payload of the UDP packet, gets interpreted as RTP. So we are going to apply a filter based on port. Now when we did that analysis, we actually found that all clients, when they're using RTP, end up using default ports like 4000. This actually makes doing this easy. However, even if the client used non-standard ports, all you would have to do then is specify the port over here. There's really no difference in the analysis. So now what we could do is basically say -d decode as udp.port equals 4000. We know that is the client port based on our analysis of the PCAP, comma, decode as RTP. Now, when we go ahead and hit an enter, we end up seeing a lot of traffic, including RTP traffic. And you can clearly see now the RTP has been decoded. So let's apply a filter just for RTP traffic. And there you go. We have managed to decode the traffic as RTP using tshark. Now, if you wanted to look at the streams and all of that information, there is an option for summaries, which is tshark -g, actually -z, and we can get different summaries. The one we are interested in is RTP traffic. We can see that there is one here called RTP streams. So I'm going to go back here, do a -z RTP, comma, streams. I'm going to mention a -q as well so that we don't see all the packets, or else if we just hit an enter right now, we end up seeing all the packets as well. I don't want that. So I'm actually going to do a -q, which is quiet mode. Do not show packets. So in the end, what happens is we just get the summary. There we go. So we can clearly see that there are two streams in this packet. And similarly, if you were to analyze the normal call two parties.pcap, we see there are detected 4 streams, right? We can see all the IP addresses, etc. Fantastic. So what we've done is we've made sure that now using tshark, we can exactly do the same decode as option as with Wireshark. Now what I want you to remember is this part here, -d udp.port equals 4000, RTP, which is the way by which we can mention the decode as filter in tshark. In the next video, we'll actually just use this part and see how we can patch pcap to wave.sh so that it can be used for SIP over TLS plus RTP traffic. So I hope you enjoyed this video. If you have, please recommend us to your friends and colleagues. Thank you.